Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizal Hadi bin Zulkifli. So, as an introduction for our project, so as we all know, with our recent site visit to Malaysian Green Technology and Climate Change Corporation, which plays a very crucial role in advancing sustainable development and combating climate change in Malaysia. So, MGTC also stands and a strong foot in of driving our nation towards a low carbon and also resource efficient economy through innovative initiative across the energy transportation, waste management, and water conservation sector. So, as a key point to talk about, MTTC efforts contributes a lot to the global climate action goals, which does influence the international effort to combat the climate change, which is a very huge issue in the world nowadays. And MTT also drives the renewable energy adoption and creates economic opportunity to the people in Malaysia in the green sector, which does enhance our national economic resilience. And the MGTC building itself exemplifies the eco-friendly architecture, showcasing the technologies such as the solar panels, the radiant cooling system, the energy efficient system, and the double glazing window as a simple example that which very efficient to reduce the environmental impact and operational cost. Okay, Assalamualaikum warahmatullahi wabarakatuh. So, as for a summary of issues, there are a few issues that we have identified, which is one of them is the high initial and maintenance cost, which, as we all know, the installation of green technology is not as easy or affordable as we think. The double glazing window or solar panels involve a very higher upfront cost compared to other conventional material, which that also doesn't include the ongoing maintenance and repair, which requires specialized technicians, specialized materials, which is potentially also increase our expenditure long term. So, as for the second issue I want to discuss is about the environmental impact. So, the production and disposal of advanced building materials such as the photovoltaic cell and the specialized insulation do contribute to the environmental pollution and resource depletion. It's not a huge issue, but it's still an issue because if not managed correctly in the right procedure, it can actually cause pollution. So, the extraction of rare materials for the green technology can have a significant environmental effect if did not managed sustainably. So, for the third issue is about the technological obsolescence, which is the meaning of technological obsolescence is a technical product which is doesn't needed anymore or doesn't wanted anymore, but still working, but it's not needed anymore. So that's for the technological obsolescence. So to include in this is the rapid advance in green technology, which lead to the component being outdated and less efficient over time. So that's very similar to the technological obsolescence. So when we upgrade to the new technology, it obviously will add to the cost and affect the building economy viability. So for the last issue that we have identified is the system failure and energy inefficiency. So the system like the radiant cooling and or the energy efficient lighting sensor is very exposed to being error, having a malfunction. So it's when this type of situation happens, it leads to the huge energy efficiencies. So there's also in the term of urban heat island, which is what we call when a building is with the large glass surface and thus use the reflective materials such as the windows, double glazing windows that used in the MGTC. This effect is very bad to the temperature, to the humidity of the building, which can impact the exacerbated by the building, which is very not good to the people inside. So that's a few issues that we have identified. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazwan Azraf bin Muhammad Azman. My metric number is AE210025. Now, we move to the details of our company, which is Electrical Vanguard Sendirian Berhad. Our background and history is our company, which is Electrical Vanguard Sendirian Berhad, established in May 2020. We started as a small Bumiputra supplier of electrical goods and for the contractors' needs. After 3 years of operations, our company became one of the fastest growing construction companies and electrical goods suppliers. Our vision is clear. We would like to provide solutions and consultation for customers' needs in terms of quality, and comfortable for the electrical goods. We would like to prioritize quality customer satisfactions. Our motto is Guard, Guide, Go Green. From this motto, we would like to combine aesthetic and operational needs to create a harmonious and complete result expected by our customers with element environmental sustainability. From the innovation sides, we would like to design low-cost concept with technical advancements at a reasonable price. We are focusing on saving energy and environmental sustainability without neglecting the comfort. Now, we move to the organization chart in our company, which is the leader, or we can call it in our position is Chief Executive Officer, which is me, Muhammad Hazwan Azraf bin Muhammad Azman. My assistant, Chief Finance Officer, is Muhammad Ikmal Arif bin Hadi. Our secretary, Muhammad Lukmanul Hakim bin Muhammad Arifin. Our manager director, which is Muhammad Fadlan Hazim bin Khairul Fadzila. And our senior engineers, which are Muhammad Faiz Farhan bin Rohaizal and Muhammad Faizul Hadi bin Zulkifli. That is our positions in our company, Electrical Vanguard Sendirian Berhad.
Hi, Assalamualaikum. My name is Muhammad Ikmal Arif bin Hadi. So I'm going to present our objective and scope of investigation. So the first objective of this project is to study the method and workflow for completing this project, identifying the learning tools that can help calculating the energy consumption and saving. For objective number 2, to reduce electricity usage by reducing electrical appliances or replacing them with more sustainable option that can save more energy. For the third objective, to produce more energy efficient designs of the building compared to the old design by integrating multiple types of energy saving features.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lukmanul Hakim bin Muhammad Arifin. So right now, to complete our group project, so I will present about the methodology. So as a basis of the retrofitting an existing building to raise an energy efficiency project plan, this methodology is intended to provide the systematic step that we have arranged and include all the project requirement. So in the first of all, we need to do a project assessment, which is we need to know the requirement to achieve an energy efficiency project plan. So for the next is the flowchart of our plan, and lastly is the presentation and also sharing. So I will go to the next slide. So this is our project plan flowchart. So first of all, in this flowchart, we need to decide the suitable building for the retrofitting. So for our group project plan, we have choose the KKTDI, which is a college in UTHM campus. And next, we need to calculating the load and designing electrical schematic. This is important to do to make sure the energy efficiency have been implemented. So next is design and planning. So in design and planning, we need to make sure the electrical system design can implement the energy efficiency, which is this is our main objective for this project. So for the next one is environmental sustainability planning, and the last one is implementation and also monitoring. For the monitoring, we need to monitor all the system that we have been doing in this retrofitting to ensure to optimize the energy efficiency in that building. So we will go to the next slide. So right now I will present about the flow of our project. So first of all, we need to do the building assessment, which is we need to calculate and analyze the building energy index of one UTHM residential, which is KKTDI. We need to consider the total gross floor area of the building, and we also monthly total electricity usage to identify the BEI index. So next is the design and planning. For design and planning, we have to ensure that the design is energy efficiency and also can be one of the green building offices. Next, PV array installation. So for this project, we have a suggestion which is using a PV array as a alternative of the electrical usage. So for the design and also in the planning phase, we will retrofit some part that can be converted into energy efficient construction because this college is located near the UTHM Parit Raja. So we have seen the potential of the PV array that can be used on the KKTDI. This is because we will get the temperature suitable temperature and also irradiance to get some energy. So next step is we can do a rainwater harvesting, which is by collecting the rainwater, it can reduce its dependence on the traditional water resources, which is we can save water and also energy required for the water treatment and also distribution. We can use the water harvesting that we collect for cleaning purposes, which is for the toilet flush or doing for other good uses. So next is the lighting fixtures and also sensors. For the lighting fixtures, we can improve the lighting efficiency. We just need to do by swapping all those old incandescent and also fluorescent bulb into energy saving LED one. This is because they not only use the less power but also last very long time. So for the sensor, we also can use an automatically switch off sensor to make sure there is no over usage on for the lighting. That also can be added here and can reduce the cost for utility bill. So that's it, all from me. I will go for the next simulation. So for the simulation, I have do the simulation in Simulink, which is a 100 kilowatt grid connected solar array. I think this simulation can be applied in the real world, which is in the KKTDI for our project plan, which is installation of PV array on the area of College Kediaman Tun Dr. Ismail. So in this simulation or in this block, I have some block and component that we need to use to make sure the solar energy can be source the KKTDI. So for the first one, we have put here the PV array, which is it will represent the PV array with maximum power output, which is 100 kilowatt. We also have put the condition, which is for the solar irradiance, we take 1.430 for the average sun irradiance in Malaysia. And for the temperature, I'm also take the weather data from the Google, which is average weather or temperature in Parit Raja is 28 degrees Celsius. So next, we also put a MPPT controller, which is it used to observe the technique to maximize the power extraction from the PV array. Next, we also use a boost converter, which is a DC AC converter that step up the voltage from the PV array to a higher DC voltage that's suitable for the inverter. So for the filter capacity bank, we also use a 10 kVAR capacitor bank used to filter harmonic produced by VSC to improve the power quality. So for the last one is the utility grid. So in the utility grid, we will put the subsystem there, which is the load for a suitable load for a KKTDI college. So after doing the simulation, we get the output for the power from the solar PV array, which is 17.18 kilowatt. So from this simulation, we assume that with usage of 12 string and 5 series connected PV array, which is equal to 60 solar cell, it will produce around 17.18 kilowatt daily. So for our calculation, it is very good for coverage the conventional electrical resources. So it will cut the cost by not depending only on the conventional resources, electricity. So I think that's all from me. Thank you.
Okay, hi and hello. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizal Hadi. My metric number is BE220105. Here I will present to you about analysis and discussion. For the first one of analysis, building energy index BEI. The BEI is determined by the sum of the gross floor area of all buildings and the total power consumption over the course of the year. In 2016, the BEI computation was used by KKTDI as a benchmark to assess the efficiency of the suggested retrofitting solutions. Okay, the second one, proposed energy savings solution. We got 2 points here. The first one, solar photovoltaic array. An analysis was conducted on a 100 kilowatt solar PV system that is connected to the grid in order to evaluate its capacity for conserving energy. The second point is solar PV effectiveness analysis. Elevated solar irradiance and temperature, the proximity of KKTDI to UTSM project allows it to take the advantage of a steady supply of sunlight and favorable temperatures, which are ideal of generating solar power. Okay, the third one, lighting and sensor analysis. LED, the first one for efficiency lighting sensors, energy efficiency. LED lights are renowned for their reduced power consumption and extend lifespan in comparison to conventional bulbs, resulting in substantial energy savings. The second one, smart control. By combining intelligent LED bulbs with motion sensors, lighting usage can be optimized, resulting in reduced energy consumption and improved building efficiency. Okay, for the discussion, the first point is initial investment. Although the upfront expense for installing solar PV system and energy efficient lighting can be substantial. The second one, continuing maintenance and monitoring. Continuing maintenance and monitoring are essential to ensure the ongoing effectiveness of the retrofitting solution. An energy monitoring system that operates in real time can assist in identifying specific areas that can be further optimized. Okay, the last point is scalability. The solution adopted at KKTDI can be used as a blueprint for other blueprints within the education campus and beyond, encouraged by the acceptance of energy efficient techniques. Okay, that's all. Okay, we continue our presentation. Okay, this is our floor plan, single diagram and the calculation. Okay, this is our floor plan of the one. This is floor plan for one room at KKTDI. This is the hall, this is the room, and the room. This is the toilet and the kitchen. Okay, here we got a fuse lamp, switch, fan, and the other things. Okay, this is the single diagram, and this is the calculation. So this is the final result we get for the suitable MCB and the others. Okay, that's all for me. Thank you.
Okay, next for the conclusion for this project. In conclusion, this project has demonstrated the significant potential for energy conservation and sustainability through the retrofitting of College Kediaman Tun Dr. Ismail at UTHM's main campus. By integrating energy efficiency solutions such as solar photovoltaic systems, rainwater harvesting, and LED lighting with smart sensors, we have outlined a comprehensive approach to reducing energy consumption and environment impact. Ultimately, the project aligned with the objectives of reducing energy consumptions, minimizing environmental impact, and supporting sustainability urban development. By providing a viable blueprint for energy efficiency, this initiative paves the way for future advancements in building, retrofitting, and sustainability architecture. That's all for our team. Thank you.